Well, hello and welcome. It is time once again to try to fix something. And today on the workbench, well, we're looking at whatever's in this box. This is supposed to be, I think there's parts to two different PS5s in this box. A gentleman named Chris got in touch with me. Apparently he tried to repair these. Maybe he's repaired other things, I'm not sure, but he was going to give PS5s a try, and it did not go as planned. So he has decided to give up and donate these parts to me. So let's take a look. I've opened the box. I got it a couple months ago, I'm ashamed to say. I've just been a little too busy to look at them. But I opened the box, looked inside, just what was on top, and that was it. I have not pulled anything out. So this is kind of what we're looking at. I believe there are parts for at least, that's a lot of screws and APU clamps there. And I see a Wi-Fi module in there. So yeah, I think he actually had, toward the end of his repair, had started removing parts from one to put in the other, trying to make one working one. So one of these should be more complete as far as on the circuit board as the other, and that's probably the one I'll start looking at first. The one that's got the most chips on the board. But yeah, this should be interesting. So let me dig in here and see which one of these, because I think he put them back together just enough so he could ship them, and I do appreciate that. But I got to dig some of this stuff out and let's just see what we have. But whichever one has the PCB in it that has the most complete, that's one we're going to start with. So let me dig through these parts. There's another one. Yeah, there's some USB, there's some front panels there. I think there's another whole PS5 down in there. Yep. Okay, let me dig this out and see what's all in here. All right, well, I think I got everything out of the box. Two PS5 chassis, a couple of power supplies over there with the antenna leads, a couple of front panels, two fans. One of them did not survive the trip. Kind of got busted up, but the other one looks fine. And he was kind enough, I don't know if I mentioned his name was Chris, he was kind enough to include some notes, so we won't have to guess as to which one is which here. Let's see. Replace some caps and fuses and Wi-Fi board. Put new Southbridge on. So this is the one he was trying to fix last, and I think this one over here had become the parts donor. And I can't unfold this with one hand. Yes. New SSD controller or Southbridge, missing caps and fuses. Okay, so this has been the donor. That's fine. Alright, so we will start on this one, the one that's more complete, and see if we can bring some life back into it. I think it was trying to beep at one time, but after putting the Southbridge on, I think he told me that it would no longer try to even beep. So, okay, we'll get a start there. Alright, well, I've made it down to the circuit board in this one, because it was just slipped together. Of course, all the screws weren't in it. It didn't take very long, which I appreciate. And yeah, I can see signs of flux, but we know it's been worked on, so that's not surprising at all. And I believe this is when he did say he swapped out the Southbridge and it quit working. It quit trying to beep or anything after that, so that's where we'll be looking at first. Let's get it inside and see what we can figure out. Alright, we are inside at the workbench. We're going to take a look at this board, and right off the top of my head, that Southbridge looks a little bit askew, so we'll take a look at that real close, because that's a biggie. Let's see if we can look at it under the microscope. Yeah, I think it is a little bit crooked. I can see the pads at the side of it there. Let me switch my monitor so I can see what the microscope is showing. Yeah, you can see that well. So that's the problem. I have not tried to put power on this set, and I'm not going to until we get that straightened out, because I don't think that's sitting right. So that's one issue we'll have to address first. There's a solder ball laying around on the board. Let's go ahead and address that now before I lose track of it. Oop, where'd it go? Yeah, I found it. It landed on my hand. There it is. Okay. That can go far away into the garbage before it ends up somewhere it should not. Okay. Looks as though he tried to change the fuse out. And this could be an issue. This right up here has almost fooled me, or I think it did fool me one time. This is not a fuse. That is a 100k ohm resistor. That's what should be there, but I can tell there's a fuse. You can see the T on top of it. So a fuse has been put there, and I'm not sure what that is. Let me put a meter on that and see if that's a fuse, or if they're just the fuse and the 100k ohm resistor are backwards or not. Let's just see. What is this? What are you? Nope, 0 ohms, so that does look like a fuse. And this looks like a fuse as well, and it is 0 ohms. So, yeah, this should be a 100k ohm resistor, so we'll straighten that out. What else? Doing those two things, correcting that resistor and straightening this out, getting this Southbridge aligned properly would get us moved in the right direction. This is supposed to be, I think, a replacement one. It is a 61GG. It is indeed. So maybe we'll just pull this one off and reball it. Just look around the board. See if anything else is going on. Anything around the HDMI circuit. Port looks pretty good. Encoder I see looks fine. Just have a look around. Back side of the RAM. You can tell the little capacitors there. SSD. It looks perfectly straight. I don't see any signs of flux around it, so I'm guessing it has not been changed. I don't know for sure. Okay, that IC has been changed. Just have to remember that. I don't recall what that makes, but we need to keep an eye on it. It's going to be a little DC-DC converter. Okay. Let's take a look at the other side of the board. Maybe we'll start here behind the Southbridge area. Just trying to see if there's anything missing. Any components knocked off. Okay, this little DC-DC converter here has been swapped out. And looks like the fuse has been changed. Let me check that fuse right quick like. Switch to continuity mode. Okay, well, the fuse is not open. Okay. This is another small DC-DC converter. Can't remember what it makes. I'm thinking it's either 1.8 or 2 volts or something like that. What else? What else? Let's go to the other side of the board. Okay. Lots of flux around that. We might reflow that a little and clean that up so we can get a good look at those joints. That one looks to be original. Oh, there's some flux around that capacitor right there. Okay, a lot of flux in this area. There's a resistor that's about to fall off the board, looks like. Let me get that back in focus. I apologize. Yeah, that looks like it's gotten flowed out of place. We need to address that. Focus. Some scratch there on the board around that resistor. This is behind the SSD controller. There's the power supply for the SSD. Doesn't look like it's been messed with. Looks factory fresh. Some more DC-DC converters here. I don't remember if this is the one he said he changed out the Wi-Fi module on. Let me go back and let's look. Here's the Wi-Fi module. Yeah, there's a lot of flux there. A lot of flux there. Got the fan connectors a little bit singed, which is why I always, do this Wi-Fi module from the bottom side. Just to avoid, damaging plastic parts. Especially like these little connectors. Those things won't take a lot of heat. They will disintegrate on you. All right, let's look behind the Bluetooth Wi-Fi module. The capacitor looks like it's been changed or something's going on there. I want to see. I want to see if we have any shorts around this module. Let me get some ground. Let me get some things back in frame. No short there. No short there. Reach 200 ohms. 200 ohms. So no, that's ground right there. This board should, this module I believe uses 1.8 and 3.3 to the Wi-Fi module. And they don't seem to be shorted. Okay. Well, that's what I see for now. So let me get started on some of this. I'm probably going to go ahead and start with this Southbridge. Pull that off, reball it. Let's look at let's see if we can look at this Southbridge from the side. Bear with me for a moment. Yep, that's definitely not down. Make sure that's coming through. Anyway, it's floating in the air. This does look like it was replaced. It looks like it was, reballed with, this is a replacement one. And why does that ball there look broken? Not sure if I can zoom in and show that, but yeah. You see that ball has broken loose from the IC. That's not coming through too well. I apologize. That one. Very odd. Okay, look at the other side. Let me zoom back out. I was mega zoomed in there. But yeah, you can see it's not on the pads right there. So that's definitely a good place to start. We'll pull this off, reball it, clean up some other areas, and see what it does. Sound like a plan? Well, our Southbridge has been removed, reballed, and replaced. Let's see. I replaced this resistor over there. There was a fuse installed where a 100K resistor should be right. If I can get it to focus, right in there. So yeah, this resistor right here had a fuse in its place, so that's been fixed. This fuse here appears to be good. I'm not sure if it's the correct size. We'll figure that out if there's a problem. I've done some cleanup around the board, just some little touch up of some areas that have been soldered on. Straighten some components out. Just the usual, little things. I have checked. There is no short on the 12-volt rail. There's no short on the 5-volt rail. So at this point, I think we are safe to check and see how much current this board's drawing when we apply 12 volts to it. All right, polarity is correct. Let's see what happens if we apply 12 volts to it. Let me get over here where you can see. Wow, 290. All right, that looks normal. 297. And kind of hanging there. It's hanging right there. That's not normal. We're hanging at 300 milliamps when we come back down. Let me give it another try. I don't think that does not look good. I mean, the current draw doesn't look bad, but the length of time that it hangs there. Not good. Okay, so I think we still have a problem. I'm wondering if our problem is going to be in this area here. I know Chris said that he had replaced the Wi-Fi module, and the initialization will hang like that if it can't talk to that Wi-Fi module for whatever reason. It could be that it's missing a rail. I'll check here in a minute and see if it's getting 1.8 and 3.3. Or if it's just some of the pins aren't connected properly. If it can't talk to it, it will hang like that. There's other things that can make it hang, but that's a common one if it can't talk to that Wi-Fi module. Because you think about it, there's only so many things that are powered on when this thing initializes. It turns on the Southbridge, loads its software off the flash memory, and it will talk to the SSD controller to pull the rest of its stuff, and it'll talk to the Wi-Fi module, because those are things that all have to be on, in standby, because you can turn on the console with your remote. So it has to have power. So we'll check those areas. But the current draw looked pretty good. I'm surprised. Let me get set up, and we'll just confirm that this module is getting 1.8 and 3.3. We can check on these capacitors on the back right here, and we'll go from there. All right, so our board is not totally dead, but we're not quite there yet, not where we should be. Let's take a look, if we could, in a few places. Move this solder out of the way. I hate to leave that laying around because it'll end up under a board. Just my luck. Let me get things situated. There we are. So, let me get a ground wire. All right. I want to see, I'm going to be looking right here in this corner, if we're getting 1.8 and 3.3 to that Wi-Fi module. Trying to untangle my leads. Okay. Let me get my hand on the power button, on the power supply. What do we have right here? I'm going to turn it on. 3.3. All right. What about right here? 1.8. That looks perfectly fine. Let's just have a look while we're here. I'm pretty sure this stuff here is working because our Southbridge seems to be working. Like this should be, I believe, 3.3. This should be 1.15. I'm in the wrong spot. Yeah, 1.15. I was on the ground side. 1.15. This is like 2 volts, is it? 3.3. I'll find that 2 volts. 1.15. About this one. Yeah, 1.98. That's what I was looking for. That all looks completely normal. And the current draw makes me think the Southbridge is good. It makes me think that the Southbridge is trying to talk to something and it's not getting a response. So it hangs and it waits for it. It'll do that if it's trying to talk to the SSD controller. Although usually when I've seen that, the current draw is somewhat less. Like 250 or something. This looks like full current draw. We're getting our supply voltage. I'm still leaning toward this Wi-Fi module, although I'm just trying to persuade myself of other options here. 3.3. There's some other small. Of course, this is the supply around the SSD controller. I could check that, but I don't think that's a problem. What is this right here? That's 5 volts in. 2.08 out. That sounds normal. Get this back in the shop. My leads are probably going to come loose. And this right here, I think, is the 1.8. Yes. I think that's the 1.8 that ends up over here. And the 3.3 was like on the other side or something. What is this? 5 volts in. What does it put out? 1.98. That looks fine. Looks completely fine. Thought there was another DC-DC converter over here that had been soldered on, like over here. But this stuff shouldn't really be involved until you go to turn it on, I don't believe. We're not that far along. We could check around the SSD controller here. Like, is this 2.5? 0.8. I was close. There's 1.2. What is this? 2.5. And this is another 1.2, I believe. Yes. That all looks beautiful. No problem there. I'm leaning toward the Wi-Fi module. Either, you know, taking it off and reballing it and putting it back down, or just replacing it. I'm going to do some checks in diode mode. Some of these differential pairs going underneath the Bluetooth Wi-Fi module over here. There's some test pads. You can kind of see them. I'm just kind of curious if they have diode readings, like they're connected to something up under there. That looks fine. What else? This module is a AWXM 546. Yeah. XM. I think it's 546. Okay, I'm not sure if I have one of those. Okay, let's pull that off, and we will either reball it or we'll replace it. Alright, well, our Bluetooth Wi-Fi module has been reballed, if I can get that to focus. Turned out pretty good. That's the same module, just reballed it. I just wanted to show you real quick, like I have, there's the empty spot where the module would go. I'm going to supply 12 volts to it and just kind of show you what the current looks like when there is no module, or when it can't talk to its module. Let's just see, is that connected? Nope. Try this cable. So I'm just going to do that right quick light, give it 12 volts, see what our current looks like. 270. Now that's more what I was expecting. 270, and it'll just hang there like that. And then it should eventually go back to 9, 10 milliamps or so. Eventually. Maybe. Alright, you see how it hangs a long time. So, yeah, maybe this is not a Wi-Fi module because it hangs a lot longer. If it's not there. Alright, let's get it installed and see if it makes any difference. Well, our Bluetooth Wi-Fi module has been reinstalled, and I was just admiring the balls underneath it. You can't see them, but they do look good. So I can get this to focus. Let's just see how much current this thing draws now, because what we're looking for is for it to go up to 300 milliamps and hang there for maybe, say, 1 to 2 seconds. And that's about it. That's what we'd like. So let's see what happens now. 300 milliamps, come back down. No. No, we're still hanging. Yeah, that's way too long. Way too long. Okay, that's not it. And unless that Bluetooth Wi-Fi module is just bad, and I don't think that's it. There's something else. Something else. Well, I've been looking around this board, trying to find any kind of a possible problem. Been kind of focusing on areas that I can tell have had work on it before. And I think I may have found something. If we can take a look under the microscope here. Let's take a look around this chip right here. Let me get this meter in continuity mode. And you can see the flux around that chip. I'm pretty sure she has been reflowed or replaced or something. But if we check right here, that's a 1 ohm short to ground. See, nothing up here. So, is it the chip? Is it this capacitor? Or is it wherever this goes? And I don't know where this goes. Might have to trace that down, but pretty dead short, 1 ohm. Let's see if we can take that IC off and see if that relieves our short or not. And there's a chance. Get my nozzle back on. Let's try about 420 Celsius. This thing's going to have a heat sink pad underneath it, so it's going to take a little heat to get it off. Alright, the chip is off. Now is our short. Short is still there. Let's move that capacitor out of the way. Park it right over there. Oops. Still shorted to ground. I don't suppose that little capacitor there is going to be the issue. I doubt it. We'll move it though. That doesn't actually go to ground though. I don't think that can be our trouble. That doesn't go to ground. So it's whatever circuit this feeds. Which is probably something on the other side of the board. Like that, which is, this is what's on the other side of the board. No short there. No short there. Alright, there's that short. Still doesn't, I don't know where it goes. That's normal, it's 0.8 of an ohm. It's reading 1 ohm short to ground. This is 8 ohms up here. Different circuit, so I'm not sure where that goes. Just seems to connect to a via here. Doesn't seem to be going to this circuit. Okay, where does it go then? Something over here? Where does that go? Well, one would think it would be something nearby. I mean, why else would you mount it right there? does it go? See, this isn't ground, so that capacitor can't be shorting us to ground. That has to go to something. Oh, that's 3 ohms. That's 1 ohm. 3 ohms. 0.57, 0.3. That's very low, whatever that is right there. 1 ohm over there. A couple of large MOSFETs here. 1.31 ohms. That's the gate of it. Does not seem to be shorted. .36. I think that's normal for that to be low. 1.4, 11.7. I think that's normal. That right there. Nothing. So where does this go? I mean, that's showing like one ohm away from that. Where does that go? Let me just do some checks like that pad there, 3.7. That one is 0.25 or so. Let's compare it to a known good board, a working board. OL and OL. Is this the same? I'm sorry, I grabbed the wrong board. This is an EDM10. EDM20. Slightly different in that area. Yeah, the 10 has another IC right here. So of course no short there. It's 277 ohms right there where we have a short. If we go over here, yep, that's, yeah, really low. That's 0.20, and that is like 3.94 ohms. So that's totally normal. Where does this go? All right, let me hunt around for a little bit and see if I can figure out where that goes. Well, I decided to break out the thermal camera, see if we can locate where this is going. I can't find it going anywhere, nearby. And it kind of only leaves one place, I'm afraid. That's the APU. If I turn this on, just deciding to calibrate at that moment. Oh, there you go. I'm pointing in the wrong place. See the corner of the APU right there? I'm turning the power on and off. I'm injecting 1 volt. It's drawing 600 milliamps right in that corner of that APU. See it light up? Yep. Okay. Let's take a look at that area under the microscope. All right, let's take a look under the microscope at that corner of the APU if we could. And if I'm not mistaken, we have a crack right in there. I'm not sure how well that's showing up on camera. But yeah, right in there. That whole corner is busted. Nice and crunchy. And that's exactly where she's getting hot. So I'm not sure if that's why she's, slow to, initialize, but at this point it doesn't really matter. At this point, it just doesn't really matter. I'm afraid that APU is going to be dead. I'm not sure what that voltage does, what its purpose is, but yeah, it looks like that's the end of the line for this one. Unfortunately, dead APU. And it's not the main rails that are shorted. There's other rails that go into this APU, and I don't know what they do, but there are other rails, and that's one of them there apparently. And yeah, we have a short. So I'm going to call this one right here, unfortunately. No joy on this one. So anyway, we do have one more that Chris sent me that we'll be taking a look at. Maybe we'll have more luck with that one. I hope you liked that one. Thought it was somewhat interesting, educational, entertaining. If any of the above, if you did, please give me a thumbs up. And I will see you in that very next repair. Maybe we'll have better luck then. So long for now.